Okay, so now we are going to look at the Multisim demo for the first part of the experiment, which is the series RC circuit. So we have the series RC circuit built in front of us. We are now going to use Multisim in order to find the voltage across the capacitor. More specifically, we are going to plot how the voltage across the capacitor increases from 0 to its final value. In order to do so, we will have to go to the simulate menu here. Inside the simulate menu, we will select the analysis, and inside the analysis, we will click on transient analysis. When we click on transient analysis, we will see a window with several tabs. So right now we are on the first tab, which is the analysis parameters. In the analysis parameters, the initial condition must be set to 0, which simply means that our voltage VCT must be set to 0 volt initially. The next part of this window is the parameters part, where the first data that we should enter is the start time of the simulation. So we will keep it 0, and the end time we will have to adjust it according to the behavior of the RC circuit. So for example, let us start with 0.002, and we will later see how to modify this value in order to have a clear picture of the graph that we are looking for. Leave rest of the parameters as is and move to the next tab, which is the output variables. When we move to the output variables, we will see a number of nodes here in the left hand side of the screen. Node number 1 and node number 2. These are the nodes that are present in the circuit, and we will have to select one of these nodes in order to plot the voltage at that node. However, if you see the circuit, there are no node numbers. So this means that we will have to somehow enable the node numbers in this circuit. In order to do that, we will close this window, we will go back to our circuit, and we will right click and we will click on show. When we click on show, we will see that there is an entry called show node names that is unchecked. We will simply check it and click OK. Now you can see that the node numbers have appeared. So this node has been labeled as 1, the second node is labeled as 2, and this node has been labeled as 0. Now let us go back to the simulate menu, select transient analysis. These values have been reset because we pressed the cancel button, so we will have to again set it to 0. We will set the start time to 0, change the stop time to 0.002, move to the output variable section. Now since we are interested in plotting the voltage across the capacitor, we will select node number 2 for plotting. Simply clicking on number 2 will not work. We will have to press this button in order to move that node to the right hand side. So now node number 2 is on the right hand side, and this is the node that will be actually plotted. We will now press simulate, and this is the graph window that we will have as a result. You can see in this graph that the voltage across the capacitor, which is labeled as V here, is increasing from 0 to 5 volt. Why did it reach to 5 volt and settle down to 5 volt? Because this is the voltage of the source. So the maximum value of the voltage across the capacitor will always be equal to the source voltage here. Now you can see that around this point, the capacitor has been completely charged and it has attained the maximum voltage. So we don't need this part of the window, this part of the graph. So this means we will have to adjust the stop point of the simulation. So let us say that we decide to stop it at 400 microseconds. So let us go back, let us close this window. We will again go to the simulate analysis, transient analysis, and change this value to 0.0004. After setting it to 0.0004, let us go back to the output variable, and we will just verify that okay, we have output variable 2 selected for simulation. We will press the simulate button, and here is the new graph. Let me enlarge this window. So now you can see that we have a very good picture, very nice picture of how the voltage across the capacitor is increasing to its final value. So you can see that it started from 0 volts and it took some time to reach to its maximum value of 5 volts. Now, if I am interested in finding the value of the voltage across this capacitor at a particular time, I will have to select the cursor. So this is the button that you will have to press in order to show cursor. I'm going to click this button, and we have two cursors in front of us. This is the blue cursor, which is cursor number 2, and this one is the red cursor, which is cursor number 1. If I move the red cursor, only the values related to the first cursor will change. You can see that x1, which is the time value, is changing only for cursor 1. On the other hand, x2 is not changing because x2 refer to the time value for cursor number 2. Anyways, let us say that we are interested in finding the value of the voltage at time 100 microseconds. So we will move the red cursor to time 100 microsecond. You can see it on the screen. And in order to verify that we have actually moved our red cursor to 100 microsecond, let us go back to this place. Here you can see that x1 is 99.795 micro, so it's approximately 100 micro. And what is the corresponding voltage? In order to read that, you will have to read the value of y1. So y1 is the y-axis value, which is the voltage value related to cursor number 1. So it is 3.8984 volts. So in this way, I have just managed to find the voltage across the capacitor VC at time 100 microseconds. And that VC is 3.8984. This is the value that you will have to actually record in your tables. Let me show you. In your report and your manual, you will see these tables. So the first line of this table, which is related to the simulation, you will have to fill it. And you can see that there are different values of time in milliseconds. So for example, if you are interested in finding the value of VC at time 0.05 millisecond, you will have to repeat the procedure that we have just shown you on the Multisim screen. So with this, we end our Okay guys, so now let us look at the series RLC circuit using Multisim. As you can see that the circuit is ready, and we have also shown the nodes. So the node numbers here are 0, 4, 5 and 6. And we are interested in the voltage at node number 4. So when we are going to simulate, we will specify node number 4. As with the previous demo, we will have to go to the simulate menu, select analysis, and then transient analysis. The initial condition, as before, should be set to 0. So it is already set to 0. And the start time and the stop times have been set to 0 and 0.001. If there is a need, we can adjust them later. Let us leave them as is. Next, we will have to select node number 4 in order to display at the output window. So we go to the output variables, and we have already selected node number 4. We are now ready to simulate our circuit. So we will press the simulate button, and this is the window that we will get. And you can easily see from the graph that in this circuit, we are dealing with an underdamped case. That's why we see these oscillations. However, after some time, these oscillations die out, and we have a constant value of the output voltage, which is constant at 5 volts. And you can now use the procedure that was described in the previous demo to get the readings. Thank you.
Okay students, so you have now completed the software demo, and we will now start the hardware demo. And we have connected the RC series circuit. As you can see, this is the resistor 3 kilo ohm, this is the capacitor 22 microfarad. And as you have learned from the previous experiments, So we have used a function generator and oscilloscope. The signal from the function generator is given as a source signal to the circuit, and we are also displaying the source signal on the channel 1 of the oscilloscope. We will use the channel 2 to see the voltage across the capacitor. Now, different from the previous experiments, in this experiment the input from the function generator is a square wave, and square wave of 5 amplitude. Now let's see how we can generate the square wave. So students, you can see that we can just press the square wave button and we will get the square wave. Now we have to get the amplitude 5 volt and frequency is 1 kilohertz. Let's first set the frequency. So we will press the frequency button and we will select 1 kilohertz. So you can see it's now selected, and now we will go back and we will set the amplitude. The amplitude here is 5 volts. Now we will generate 5 volts amplitude by selecting the amplitude button and pressing 5 volt peak to peak. Why it's 5 volt peak to peak? Because it's a square wave, and you know that square wave looks like this. So you can see, so this is 0 volt, this is 5 volt. So we can say this is 5 volt from peak to peak. Okay, now students, if you see the voltage that has been generated at the moment, it's going from minus 2.5 to 2.5 volt. So it means this waveform requires a DC shift of 2.5 volt, which we can provide by using offset option. So there is an offset option here, and we will set 2.5 volts, and now you can see we have generated the required waveform, which is a square wave from 0 to 5 volt. Now our signal input signal is ready. Now let's see it also on the oscilloscope. So now students, you can see this yellow signal is the channel 1 signal, which is the input square wave from 0 to 5 volt, and this blue signal is the signal which is at the channel 2. It's the voltage across the capacitor. Now you can see that the voltage across the capacitor shows the charging behavior. So as the capacitor is charging, it takes some time to reach the final value, which is 5 volt, and when the input voltage gets 0, the capacitor discharges, and it discharges, and all the energy is dissipated across the resistor, and the value is returned to 0 volt. So you can see from the blue curve, it shows the capacitor charging and discharging behavior. Now students, you should know how you can read the value at a certain point by using cursor. So we have a cursor option here in the oscilloscope, and if we press the cursor option, we will get the type menu here. So we have to we can select it. For example, type is off, it means the cursor is removed. Type is amplitude, it means we can read at different amplitude, but we have to read at different times. So that's why we will set the type time. Now if we move this this button, if we rotate it, we can move the cursor at different times. For example, we want to read the value at 260 microseconds. So at the moment the cursor is at 260 microseconds, showing the voltage is 4.96 volts. Let's say we want to read at 100 microsecond. So we will move it to 100 microsecond, and we can see the voltage is 3.92 volts. Thank you. Okay students, now we will connect the second circuit, which is second order RLC circuit. So we have already connected it. So we have a 220 ohm resistor, we have inductor 12 millihenry, and we have a capacitor 22 the same value 22 nanofarad. The same input has been provided, and we are again interested in finding the voltage across the capacitor. So everything is same. So we have displayed it now on the oscilloscope. So you can see the voltage across the capacitor, which is shown in blue. It's basically displaying an underdamped response. This you can recall also from the software demo. So again, you can measure the voltage at different times using the same method which we showed for the first order series RC circuit, and you can clearly also see the oscillations by just we have now expanded the time base, so you can see that we have the voltage shoots as we know in the under time response, and then finally it settles down to the final value. Thank you.